Hi everyone. In this video we are going to learn how to calculate the molecular weight of a liquid through vaporization. The problem asks, an unknown liquid was vaporized in a 250 milliliter flask at 121 degrees Celsius and 786 millimeters of mercury. The vapor was condensed and found to have a mass of 1.28 grams. Determine the molecular weight of an unknown liquid. Now, let's get a sense of what our experiment is going to look like. Might help us to answer the question. Here you have a pretty rudimentary setup. We have our 250 milliliter Erlenmeyer flask. We have our unknown liquid here. This is what we're trying to figure out the molecular weight of. We're going to heat this liquid using water, and we call this a hot water bath. We assume that the temperature of the water, 121 degrees Celsius, is the same as the liquid that's going to evaporate. Now, the question gave us the temperature of the water in 121 degrees Celsius. Since we're in our gas laws unit, we want to change that to Kelvin by adding 273. It also told us that the flask had a pressure of 786 millimeters of mercury. I went ahead and changed that to ATMs because we are going to need the ideal gas law. Now, before we get started with the ideal gas law, I think it's important to think about, in order to find the molecular weight of the gas, we need moles and we need mass. Molecular weight equals grams per mole. Just like you would say the molar mass of water is 18 grams per mole, we're trying to figure out what the molecular weight of this liquid is, and we're going to use grams per mole. So let's go ahead and get started. We're going to set up PV equals nRT. We know the pressure, we know the volume. We're going to solve for moles. Our R is on the formula sheet. We just have to make sure we use the right one, and we know temperature. I'm going to solve this for N, and when we solve this for N, we should get P times V over R times T. N equals pressure, 1.03 ATMs. Remember, we had to convert this to ATMs. We divided by 760 millimeters of mercury to get to ATMs. Next is our volume. We have a 250 milliliter flask. We want that in liters. So 0.250 liters. We're going to divide by R, 0.08206 liters times atmospheres over moles times Kelvin. And then finally our temperature, 394 Kelvin. Remember, this is the same as this after we convert to Kelvin. ATMs cancels, liters cancels, Kelvins cancel. We're going to be left with moles. When we calculate on our calculator, we should get 0.00800 moles. I used 3 sig figs. Now, molecular weight is grams per mole. In the question, we were told 128. So we're going to take 1.28 grams divided by our moles, and we get our molecular weight, which is 160 grams per mole. So once again, in the question, we were asked to determine the molecular weight of the unknown compound. We used the ideal gas law to find moles. We took mass divided by moles, and we found our molecular weight. Thanks for watching.